Today we are going to be handling metals and their compounds. And we're going to start from the introduction of the concept of metals, and also their compounds. So first, I'm going to define what metals are. Metals generally can be defined as elements which their atoms ionize by electron loss. This makes them generally different from the non-metals which ionize by electron gain. Now, the physical properties of metals are generally based on the arrangement of their atoms or molecules in crystal lattices in their structures, and the chemical properties are generally dependent on the number of valence electrons of the metals. Now, generally, metals can be classified into the group 1 metals, which are also known as the alkali metals, and also the group 2 metals, which are known as the alkali earth metals. And then the group 3 metals. Now, by definition, the group 1 metals, also known as the alkali metals, are those metals which have one valence electron on their outermost shell. And common examples are sodium. Now, if you look at sodium, sodium has atomic number of 11. And based on the arrangement, the SPDF shell arrangement, you see that on the last shell, on the outermost shell, sodium will have one electron on the outermost shell because it's going to be 2, 8, 1. Another example is potassium, which is element 19. Now, based on the arrangement of the electrons also in the SPDF configuration, we are going to have 2, 8, 8, 1. So you see that the group 1 metals, also known as the alkali metals, have one electron on the outermost shell. Now, the group 2 metals, on the other hand, have 2 electrons on the outermost shell based on the electronic configuration, the SPDF electronic configuration. And an example of that is calcium. Now, calcium is element 20, which means it will have electronic configuration of 2, 8, 8, 2. Then, for the group 3 metals, they are the metals that have 3 electrons on the outermost shell. An common example is aluminium. Now, for aluminium is number 14. So it will be 2, 8, 8, 2. So you see that it's like 2, 2, 13. So it will be 2, 8, 3. And you see that it has one electron on the outermost shell. So next we are going to look at
define metal, write it.
The full definition. Next, we're going to be looking at the general physical and chemical properties of the metals. Now, generally, there are certain properties that are characteristic to all the metals, generally. So, some of these properties include high melting and boiling points. Now, because of the crystal arrangement, the arrangement of the atoms in the crystal lattice of their structures, they tend to form strong bonds with one another. So these strong bonds makes it very, very difficult for the atoms to disintegrate in the crystal lattice. So making it to have very high melting point, because you have to heat the metal to a very, very high temperature for the atoms to disintegrate in order to form either liquids or gases. Then the boiling points of metals are also very, very high. When a metal is in its liquid form, before it begins to boil, that is before its vapor pressure is equal to the atmospheric pressure, is going to have to be heated to a very, very high temperature before you achieve that. A typical example will be when heating iron. You see that iron will have to be heated to a very, very red hot high temperature before it disintegrates or becomes liquid or otherwise. Another property is luster. Now, for an element to be lustrous or to have a characteristic of luster, it means it has a characteristic shine. It gives off a certain reflection of light. So we know from certain practical examples of metals like our iron, our copper, we see that they are reflective, they shine, they reflect light generally. Then we have malleability. Now, malleability is the characteristic which enables metals to be hammered into various shapes or into various sheets. A typical example is our metallic sheets or our steel sheets. We see how they are often hammered into various shapes, into various sizes, and into various diameters of thickness. Hard but not brittle is the next characteristic. Now, metals are very, very hard, obviously, from our practical examples like iron, gold, copper, they are very, very hard. But this doesn't mean that they are brittle, which means they don't break easily. So metals generally are very, very hard. They have a very high tensile strength before they even bend or break. But that doesn't mean they break easily. So they are very, very hard but not brittle. Then they are good conductors. Good conductors of heat and electricity. Now, from the definition of the metals, we see that they have very, very few valence electrons on the outermost shell. Now, these valence electrons enable them to carry electric charges easily, between various atoms and also to one another, which makes them very, very good conductors of heat and electricity. As for heat, also because of this valence electron, heat is the energy which is transferred as a result of difference in temperature. So the transfer of heat is made easier as a result of these free electrons of the metals. So this makes them very, very good conductors of heat and electricity. Then ductility. And ductility is the property of metals to be drawn into wires, into thin, very, very thin wires. For a typical example is the cable or conduit wires that we see all around. Most of them are made from various elements such as copper, aluminium. It utilizes the ability to be drawn into sheets, into very, very thin wires, in order to manufacture conductors. This is another property also. And the next property we'll be looking at is relatively high density. Now, metals are very, very dense because of their atomic masses. You see that various metals, have very, very dense properties. They are very thick. It takes certain strength or certain amount of force to break or cut into various metals. And it also contributes to the property of them being hard but not brittle. Then sonorous. Now, the property sonorous means it gives out a musical note when struck. So from our everyday activities, striking of bells, hitting certain objects with other objects, we see that whenever you strike a metal, it gives off a certain musical note. It gives off a certain note, and these notes are applied in various musical instruments, such as the drums, the gong, obviously the local gongs we use. So that's the ability of metals to give off a note. Now, these properties are characteristics to major elements, so many metals, but it's not characteristic to all the metals, such as sodium. Now, for sodium, you see that sodium goes against the property of metals having high melting and boiling point, because sodium has a relatively low melting point of 97 degrees Celsius. Now this is lower than the boiling point of water, so it's relatively low, and at this temperature sodium will melt. So it goes against the property that says metals have relatively high melting and low boiling point. Then sodium also is not hard, it's actually a soft grayish metal. It's gray in color and it's soft. Then another exception is potassium. Potassium has a melting point of 63 degrees Celsius. And just like sodium, it's not hard, it's a soft metal also. Then number 3 is mercury. Now mercury is the only metal that is liquid at room temperature. It has a very, very low melting point of minus 39 degrees Celsius. And it's liquid at room temperature. Then the general chemical properties of metal I will also be looking at next.